Well, good morning, good afternoon, good evening, good night, wherever anybody may be across our world. Thanks so much for joining us here live on Serverless Office Hours, one of my favorite parts of the week. And we're streaming on the AWS Twitch channel, so if you're joining us from there, and if you also via YouTube on Serverless Land and also on LinkedIn Live. My name is Julian Wood. I am a developer advocate for Serverless at AWS, and I'm super duper happy to have a returning guest. And unfortunately, I wasn't the first person to chat to Giedrius, but Giedrius Praspaliauskas is joining us from Oakland, California. Giedrius, welcome again to Serverless Office Hours.
Thank you. Glad to be here.
Well, great to have you. For people who haven't seen your previous stream, which we'll get onto, what has been your journey to AWS, and what excites you about doing what you do at AWS?
So I've been in tech industry for a long time, and before AWS, I worked for one of the largest United States federal systems integrator, and then I joined AWS in 2017. I worked for a few years as a solutions architect in San Francisco Bay Area with large customers here in the Bay Area, Silicon Valley. And then I went into even more niche technologies called serverless. You may know about them, and I became a specialist solutions architect focusing on serverless, which is SQS, SNS, Lambda, Event Bridge, API Gateway, step functions, and so on, and even started digging even deeper in API Gateway space. So that's how I ended up on this Twitch stream.
Well, excellent. Well, yeah, Giedrius is literally one of our internal absolute experts and works with our sort of top customers and all of you. So yeah, it's a really pleasure to talk to Giedrius, especially about what we're going to be talking about today. But before we get to Giedrius, and please don't go away, just a quick recap of what's going on in the previous world of serverless over the past week. The last stream was super fun. Harold's son, who's also literally another Lambda wizard, talked about running any web app on Lambda, and he's built this Lambda web adapter, which allows you to run, Flask and Express and all these kind of frameworks just natively in Lambda with a little bit of glue code that he's created. Yeah, really makes it amazingly easy. He even had some generative AI streaming goodness at the end of it. So really, that was a fantastic stream. Harold's awesome. And if you are building any web apps and you're wanting to know how you can do it on Lambda, it's certainly the place to look. And that's along with all other previous streams is on our Serverless Land YouTube channel, youtube.com/serverlessland. And yeah, we've got now a catalog of many years worth of great serverless content. In terms of what's new in AWS Serverless, the top two in the past week, number 3 down, just Lambda functions by Graviton available in 6 additional regions. Don't normally talk about region expansions here, but because this is such an easy win to save money and use Graviton and get a bit of a performance boost depending on your code, if you can, that is super useful. So if you weren't aware of that and you do have workloads in multiple regions, that can sort that out for you. Lambda number 2, a trusted advisor adds a new fault tolerance check. And this actually is a cool thing. If you haven't used Trusted Advisor before, just basically going to check your configuration of your Lambda functions. And this is now going to pick up if you don't have Lambda destinations or DLQ for your async Lambda functions. So just another cool automated check to make sure you are following best practices. And then Step Functions team, another one out the park, some enhanced error handling they've rolled out. This is really going to be useful to be able to look into your step functions and how they are executing, and just a whole bunch more enhanced error handling to go with that. If you are a Terraform user, well, we've got good news for you. If you've ever been using SAM, it's now generally available, the support for HashiCorp Terraform, and this allows you to locally test functions and APIs and things packaged with Terraform locally, and then to be able to deploy them using SAM. So that's really useful. And the second one down, when I was talking about step functions being on a tear, yeah, they've enhanced the Workflow Studio, which is a really, really good visual designer. And I do say, with respect to the rest of AWS, some people sort of think, AWS maybe not the best at visual designing stuff. Well, I promise you, look at step functions in the Workflow Studio. They've done an awesome job, and they've even added some more for some streamlined authoring and some blueprints and other things like that. On 26th of October, we've got EDA Day, Event-Driven Architectures Day in Nashville. We'll all be there. A whole bunch of people will be talking about the ins and outs of EDA. Lots of great speakers. So really, there are not that many tickets left. So I would suggest that you can grab them as quick as you can before they go. And yeah, that's really going to be a super useful day to be able to take your event-driven architectures and take the way you use serverless to the next level. There's a whole bunch of learning guides that have been coming out recently. Giedrius being one of them. Lambda Fundamentals is all about literally the basics of Lambda. We've got using Lambda with Apache Kafka. So this may be on-premises Kafka, can be Amazon MSK, can also be Confluent. So different ways that you can connect Kafka and Lambda. And Lambda is a really great way to be able to consume streaming things from Kafka. There's also step functions, distributed data processing with step functions, and there's also a DynamoD knowledge portal. So lots of learning paths, and that's all on serverlessland.com/learn. Realized I was a bit silly. I took off the URL for that, so apologies for that. But yeah, serverlessland.com/learn, and all these learning paths are up there, including what we're going to be talking about today in terms of APIs. And so, actually, before I get onto the APIs, obviously the other big thing at the end of the year is reInvent, and I must be silly as well. I've hidden a slide with that. And reInvent is coming up at the end of the year, so it's in Las Vegas. And before we were chatting offline before, and Giedrius, you've been to every single reInvent?
So far as I know.
Fantastic.
So from the first one where we were splitting Sands Expo floor and then Sands Convention Center with some, I don't know, it was some pharma conference at the same time. We didn't even have full venue for ourselves.
Wow, fantastic. Well, yeah, you've been there from the very beginning. So yeah, that is happening at the end of the year. Huge amount of content, lots of content planning going on internally over here. Obviously some secret announcements, some cool things that are coming out. We'll try not let too many of them slip during office hours, but yeah, really build up to reInvent. Yeah, tickets are available, get your hotels, and we'd love to see you there. It's really one of the highlights of the years for all of us at AWS. So yeah, it'd be fantastic. So yeah, don't forget reInvent at the end of the year. If you can make it, we'd love to see you. Going on slides. But yeah, today we're talking about building an API platform on AWS. So Giedrius is a real sort of API expert, and he's put together a learning guide on all of this. But Giedrius, how do we tee this up? I mean, obviously, when we're talking about, working in the cloud and even the very, early days of AWS, it was all about APIs, APIs, APIs. In fact, the success of Amazon and the success of AWS is Jeff Bezos, many moons ago saying, you need to stick everything behind an API. That is how you're going to communicate. So tell us, what can you tell us about building an API platform on AWS?
So as you mentioned, everyone does APIs. It's not like if you work in some work or if you work on some project, most likely it will be results of that project will be exposed one way or another to your partners, to different organizations, and so on and so on. So it's not that you are just, okay, here's my small piece, I will build it, and then I'm done. It will be exposed to others one way or another, and that's where API management comes into the picture. And you start maybe from smaller things, but you start with this kind of contract with whoever is consuming your APIs. And I think it was 2 or 3 years ago when at reInvent technical keynote, Werner Vogel's stated with 7 or 8 principles for API building based on our experience. And first of them was APIs are forever.
Yeah, I love that.
So you have to think about that API management and then how you're going to maintain it over time and how to make it easier. And that's where this entire end-to-end life cycle of building API, monitoring, making sure you understand what's going on with that comes into the picture. And that's what we built together with Artie, my colleague, Serverless SA, and other SAs, our technical field community members, and so on. It's kind of collective work, kind of collective wisdom that we put together into that guide that goes from the beginning, from the first things when you start planning, where there are decisions that are one-way door or two-way door decisions, as we call them. Can you change your mind afterwards? In some cases you do, in some cases it's impossible. If you start thinking, and then we'll go into that later and when we walk through that guide. For example, when you decide on your protocol, it's really extremely hard to change from one to another. Maybe you will be able to build it in parallel, but let's say if you decided to go with REST, then switching to GraphQL in the middle of the development, it's going to be a painful experience, and vice versa. At the same time, changing, let's say, endpoint type from private to public, from public to private, that's way more straightforward. Maybe somebody will start screaming that I cannot access it anymore, but that's pretty much all you're going to hear. Otherwise, nobody has to go back to their project and redevelop everything from scratch.
Yeah, I think that's such an interesting thought, especially when you think about serverless and we're all moving to sort of a native way of building things in the cloud. And you think that a lot of your code is ephemeral, there isn't storing state anywhere, and state is all sort of external. And it means it's a lot more fluid. You can add SQS queues, you can, add and remove event bridge rules and all these kind of things. But yeah, from what Werner said, that, the APIs are forever, that, it's a very serious, a thing you need to take really seriously is actually designing your API. And not just because it's forever, but it is the front door to your business. It literally defines how people are going to interact with you. And it may, your business or what you're exposing by an API may just be a small microservice, but, it literally could be your entire company. And, you don't know how big you're going to grow. And, some of these choices up front, these are some things you really want to take some time and effort to actually go over. So yeah, I like that point of, let's in fact break those down and understand which are the really important things you need to do about API design up front, and then understanding the trade-offs between them. And then, some of the things, as your product and your service and your company is going to evolve, that's your API is going to be able to evolve with you. Because I mean, APIs are, big deal.
Yes, and so we start usually with thinking about API as any other software product. It has its own API lifecycle. So as any other software product, you build it, you design it, you build it, you deploy it, you secure it before deployment, hopefully, and then scale, monitor, look for insights in those APIs. And I'm not sure, are we sharing my screen?
No, let me put that up for you.
Okay. Yeah, so this is the guidance.
Yeah, so this is the guide. I will actually put the link in the chat as well and on the screen. So, oops, in the wrong place. I'll get that on the chat and the screen. Yeah, you carry on, Giedrius.
Yeah, so on the serverless land, at the same learn area as any other guides, you can find this building API platform on AWS guide or paved path, where it goes from very beginning through entire life cycle. And let me go into life cycle. So through all those steps, building, managing adoption, scaling, and so on, there are multiple options how you can do that, multiple approaches. Some of them, as I mentioned, are kind of you decide on them once in your API lifecycle. Some others are maybe not as rigid, and then you can change them. And then in that first lesson where we talk about this API lifecycle, which is no different from any other software product, it's maybe personas are slightly different, where API developer would be different from some backend developer, front-end developer, and so on. Operations will be the same, and then business owners and consumers, they will play similar roles. So it's not something really unheard of or something that you haven't seen before if you haven't worked with APIs. And then after you understand that lifecycle, we start talking about those one-way doors, two-way doors. So first of all, protocol selection. Is it HTTP REST, WebSocket, GraphQL? We do not have much of the details on GraphQL. It's entirely different area to cover. This is mostly about HTTP and REST APIs, WebSocket APIs. So we start with protocol selection because that's, in most cases, it's one-way door. And one note on the right-hand side, on every single of those lessons or steps, you will see links to the resources. Like in this case, you select endpoint type, and then you select API topology, like centralized versus distributed. If you look on the right-hand side, and I apologize for all the scrolling back and forth, you'll see additional resources where you can go deeper into those topics, like networking with Amazon API Gateway, where we spend an hour or so with our networking TFC leads talking about how it's different or how it's similar to other types of networking, and then what typical patterns you will see there. Best practices to design API Gateway private and private integrations. It's really great white paper if you are starting to think about microservices and exposing them internally and making sure you understand how those private integrations and private endpoints work. That's white paper to look at. And then blogs, like a couple of them listed. And on each of those pages, you'll see them. So again, after selecting protocol, after deciding what kind of endpoint you will use, you also will need to decide on API topology. And that's maybe more, it's less of a vendor-specific or implementation-specific question. It is more of a API design question. It's not exactly that API on AWS or API on any other cloud vendor or on premises will be different, will be forced to use one topology or another. It is more of your API design and how do you want to segment larger APIs so they are easier to use. So once that's done, we go into next step, developing and testing. Now, when it comes to developing, I should admit the API gateway, AWS Management Console API gateway area is maybe not the most flexible tool. If you look at the beginning of this week, you mentioned step functions workflow designer. It's, I would say, one of the better IDEs that I've seen there for drag drop development, connecting services together, connecting those integrations together. When it comes to API gateway, it may lack that flexibility, to be honest. But at the same time, there are so many tools that you may be already familiar and comfortable with using coming from our partners, like starting from Postman, Smartware, Swagger Hub, Kong, Insomnia, Stoplight, and so on. All these can be used because API Gateway supports OpenAPI specification import export, and you also can include OpenAPI specification in infrastructure as a code. Let's say CloudFormation, include, transform, two things to keep in mind. So you can refer those resources that are specified in CloudFormation, like Lambda functions, VPCs, and so on, directly in your OpenAPI specification, and then just use in your infrastructure as a code. It can be Terraform, it can be CDK, anything that you are familiar with. So at that point, development, it's really flexible. You are not married to AWS Management Console and API Gateway area of that. You can use any tool available out there, and lots of them support.
That brings up a really good point about API Gateway compared to maybe a lot of other different AWS services. That because a lot of the API ecosystem is very open, and whether you've got Swagger or Open API Spec or all these kind of things, these are industry standards that are just being implemented within API Gateway. So yeah, as you say, you can import your API specs from many other kind of places. I'm sure you've obviously got to decide, but the REST API as a protocol and a decision to use, that's an industry thing. We just happen to be implementing it in API Gateway. So I suppose my bigger point, which you're alluding to, is you've got a huge amount of tools already that work with APIs, things like Postman for testing and all other kind of things. But yeah, that must make it at least a little bit easier if you are thinking of migrating to API Gateway. That some of your testing and some of the way that you've built things before could be easy enough to switch over. Is that an accurate assessment?
Yeah, it's easier to switch over. Migration becomes easier if you use industry standards. So let's say if you're if you're working on, let's say, on-premises migration to the cloud, and you have some kind of API management or API proxying solution, and you have OpenAPI definition version 2.0 called Swagger or OpenAPI 3.0, 3.01. You can just simply export, import, and you have at least that initial skeleton where we can start building integrations around available to you. And also, if you have your favorite API development tool, you don't have to retire it. You can keep using it. And as we'll talk later about the deployment, again, it's open. You can use the same tooling as you have right now for developing, for your CI/CD pipelines, deploying to production, and so on. All this will work because it's really open. It does not require, it has those extension points like OpenAPI import, OpenAPI export, And you can use those extension points, and most of the vendors will be able to tap into those extension points as well. If you look at, let's say, how Swagger Hub with API integrations work, they will allow you to automatically deploy to API gateway through those integration points without you ever touching AWS Management Console. So that openness, those extension points allow you to use any tools you are familiar with and any tools that you want to use for one reason or another. And Management Console, and especially with updated view, how it looks like for HTTP APIs, gets better and better. So eventually, in the fullness of time, will be, I hope, as flexible, as developer-friendly, as powerful as Step Functions workflow editor, where you can drag, drop around, and so on, hopefully.
Okay, I just also want to, something I thought of, and I should have brought it up when you were talking about the API lifecycle. Obviously, there are a lot of different personas that are involved in managing and running APIs, because you have an API platform that you're going to be using, and you've got a developer who's understanding how the API is all laid out. You've then obviously got code running behind those API routes, which may be in a Lambda function or a container or something like that. And then obviously, you've got a security team involved. You've got a networking team involved to connect all these things together. In terms of the API lifecycle, are there any things that you see with customers that people forget to do, or some sort of quick tips or tricks that people should think of when they're doing their as part of their planning and as part of their API, understanding the API lifecycle and then doing the planning? What are the things that people don't do that they really should be doing?
I think it is mostly, so first and biggest, maybe not a mistake, more oversight. Or forgetting to think about it from that perspective, is that API gateway, excuse me, API gateway is a front door. It's not that will fail, most likely. When we talk about scaling, you get out of the box that 10,000 requests per second quota that is soft limited, just one support ticket away from getting it increased to hundreds of thousands. API gateway will not fail at scaling. What will fail, most likely, where your bottleneck will be, its backend integration. It can be your EC2 instances out of scaling group that does not react fast enough, or your containerized workload, or maybe your DynamoDB read-write capacity limits that you set and then never thought about switching to on-demand capacity or provisioning higher read and write limits for some events. So those backend resources, that's most likely what will fail. So whenever we talk with the customers, we want to go through entire architecture. When they ask, okay, so look, we're going to have this marketing event, and how do we deal with this from API perspective? Answer usually is, okay, let's put aside API. That most likely will survive any load that you will throw at it. Let's talk about how it will affect your backend systems and how it will scale. Let's say if you have some old legacy database in the back, or some mainframe system that it will hit with that entire load, will it really survive? Have you tested it? So that's biggest. If you take one lesson from this entire discussion, take a look at your entire system that API is in front of holistically, and take a look at all the nooks and crannies, and then see, if I throw, let's say, 100,000 requests per second instead of 5,000 requests per second, which of them will break?
Yeah, no, that's a really good insight, because API gateway is the front door to your service, to your microservice, to your company, but everything behind that company, everything that's running the code or doing the database lookups needs to be able to support that.
Yeah. So with feature selection and then development, integration types, so these we talked at various venues, and there is a link to the videos that Eric created, or Eric's presentation. So I didn't know Amazon API Gateway did that from reInvent a couple years ago. They're great ones. Look at them, watch them, and he goes through all those features in depth, and other resources there from sample REST API implementation end-to-end that includes CI/CD pipelines, authentication, authorization, observability, and so on. Look at them, and we will not go maybe in all the features, all the available features. There are links in this guide, developing REST APIs, developing HTTP APIs, developing WebSocket APIs. There are plenty of features, and it's, I would say, hour and a half, 2 hours chat just on if you go through all the features. So maybe let's leave that. If anyone is interested, we can have follow-up discussions on a particular type of API and then how to develop that. And then integration types, as we already started talking, what could be behind that front door? It can be Lambda functions. It could be anything that is publicly available, any other AWS service, either publicly available or in your private VPC. Anything can be exposed to API gateway, and that's where that scaling story comes into the picture. First part is, how do you prevent access to those resources if you don't want them to be accessed except through API gateway? So that's one story, security story, and we'll talk about security in the next lesson or lifecycle step. And then second part is how it will scale, how it will handle that large load if you throw it at it. And private integration targets. Again, I mentioned the white paper about private integration targets and private endpoints. It's linked in the resources where you can look at that white paper, read it. It's really in-depth. It's really explains a lot of concepts there. It helps to understand why it is doing this particular way, how to consume those resources across maybe account boundaries, across network boundaries, and so on. And last part on the development testing. So API Gateway Console and in AWS Management Console, it has really great initial testing feature where you can, without even deploying it, you can test your API gateway directly in the console. You just put query string parameters, payload, you select what kind of method you will use, and it will allow you to send that request to the control plane, the data plane, and see logs available immediately. What is going on with that engine? Those execution logs. We'll talk about execution and access logs maybe later, but you can see what is going on, how that path, how that request is traversing the system, and if something breaks, if something is wrong with your design and develop and deployed version, you will see or version that you are working on, you will see those logs available to you immediately. So that's initial testing. Now, this is by no means all the testing you have to do. So that's while you are maybe working in more of IDE side, but any CI/CD pipeline will have that testing hopefully integrated. Unit testing, integration testing of your API gateway, security testing. In the secure part, we talk about partners available there that have some testing features like penetration and security testing. But any testing framework that you use, whatever you would use now for your development, non-API development, will work for, let's say, for mock tests, for integration tests, and also there are API-specific partner solutions like Postman has, or Swagger Hub Ready API solution, or Insomnia, and so on and so on. Those partner solutions for API testing, test development, where you can simply maybe pass that open API definition and they will generate those test stubs automatically for you. They are available there. Again, whenever you see something that, okay, I would like to have that feature in API Gateway, that's where you, if you do not see that feature, either look at this guide, shameless self-promotion, or look at our partner solutions. And most likely those third-party solutions, those partner solutions, even if they may not be specific to API Gateway, will have something for you to use.
Yeah, Giedrius, just yeah. So basic testing in the console, then all these partner solutions. But I mean, testing is a whole big world because we're not just talking about functionality testing. There's security testing. There's load testing. There's availability testing. You know, all these different kind of testing. So yeah, a lot of info over there. We do actually have a question just while you were talking over there, which Alpa Codes. Thanks for your question and joining us via Twitch. Can you remind us what a data and control plane were? Because actually, interesting, Alpa Codes. I will bring up your sort of, you know, what is a control plane, and your definition. The control plane is the part of the network that controls how data packets are forwarded. So I'm just going to take that off because it's blurring the screen. But yeah, Giedrius, how would you explain control plane and data plane?
And it's perfect segue to security, where we talk about access control for control plane and data plane. So maybe let's focus on that. Yeah, exactly. So API gateway has two parts of it. One is execute-API, what you see in API gateway API definitions, and another is API gateway. So execute API is your data plane. So that's the request that is coming into API gateway, hitting that front door, which does all the things like validate, request, checks authentication, authorization. If you're going through the entire flow, first of all, web application firewall kicks in, then authentication, then authorization, then model validation, transformation of your payload, and then it passes requests to the endpoint integration target, to the integration target in the back. So all that is your data plane. So Lambda function or containerized application that is running as containerized workload in the back and responding to those requests, that's part of your data plane of your API gateway. Now, on the other hand, you have control plane. That's how do you manage your API gateway? That's API gateway resource available to you in CloudFormation or CDK. That's where you have control over who can deploy your API, who can control particular parts of your API. Let's say if this API is kind of umbrella API for multiple teams, and each API using custom domain names and base path mapping are building into this one big API. Which of them can access what? Which of them can have what kind of access? Read only, they can deploy, they can edit it. Also, your governance part for your API, it's also part of the control plane. You can specify, let's say, rules that in this particular account or this particular organizational unit can deploy only private API endpoints because they do not work on anything that should be available to public. So they have no need to have public APIs, or all of them have to have this particular type of authorization and so on. So all those requirements for API configuration, not the data plane, not how I respond to the request, but how do I manage that API configuration? That's where control plane comes into the picture.
Yeah, no, I think that's a perfect explanation. Alpa Codes, what I will add is I think from and I'll just bring it up for people who are reading, and well, I won't read it all through. When you were talking about the control plane, I think you may be taking this documentation from a network device that also has a control plane and a data plane built into it. Now, I would think that this is in fact elevating the same idea, but it's actually just bringing it further up the stack. So the data plane is the part that actually shunts the bits around. So literally moves the packet when you do a HTTP or REST API or WebSocket request. That's actually the packet that's going all the way through, literally all the way to your Lambda function and maybe or EC2 instances coming back all the way through API gateway. That's your data that's going through. And as Giedrius says, the control plane is not controlling how those network bits are moved around, but actually controlling how the API is configured. So, creating an API gateway, deleting an API gateway, setting some, doing the configuration parameters to maybe add some authentication tokens to connect that API gateway up to a Lambda function is controlling that API. So it's not at the network level where it's controlling where bits are being sent, but maybe at the integration points where you're doing that. So you can think of the persona. This is actually what a persona would do. A human, a developer, a builder would be sitting there configuring and controlling the API, and hence that's the control. But the actual packet shifting of moving packets around, that would be the data plane. And I think that's a good point you brought up, Giedrius, about the compliance and governance, because that is a super important part of it. But again, that's controlling it too, because the governance would block an API being created if, in Giedrius's example, it was not a private API.
Yeah, and if it helps on to put that analogy in place, that okay, so a routing table in a networking control plane. You can think about building resources like /orders, /product in your API gateway, and then the method /get method post and so on, and tying them back to the backend integration targets, where maybe creating order is some Lambda function responsible for that, but listing orders, it's maybe some containerized workload. So that is your API routing table, for lack of better terms.
Yeah, I like it. Good analogy.
Okay, and then last part of security before going into partner solutions, and there are plenty of partner solutions, those usual suspects in security plane, is security at all layers. If you look at a typical, quite simple implementation of API, where you have API gateway, Lambda function, maybe DynamoDB, maybe some RDBMS like Aurora serverless in the back, plus S3 storage for your static assets, and then maybe web page itself that is hitting that API gateway front door. You have so many places and so many things where you should look at for security controls, starting from maybe AWS Shield and then WAF in combination with CloudFront, or maybe AWS WAF integrated directly with API gateway. And then you have access control on each of those services. And then you have resource policies that tell where you can call that API gateway from, and also execution policies where it tells what that API gateway instance can do with your resources, which resources it can access, and so on and so on. So think about this end to end. Again, this entire picture, entire system, not just where it will fail from scaling perspective, where it could fail, and what controls do we have on each of those services when we talk about security.
Yeah, and I think it's interesting that this is all wrapped within API security, but it's because your API is connecting to your business data. So I know some people go, oh, that's a lot of, why do I need so much security configuration with my API? Well, it's not all entirely related to your API. Your authentication between your Lambda function and your Aurora serverless database, for example, has nothing to do with your API, but is involved in your security because it's all about the end-to-end flow of the traffic. And so, yes, you want to, before you've even got your API, the security you want to be putting in, Shield for DDoS protection, or WAF for filtering rules, and content checking and all that kind of thing. And that's before it's even got to CloudFront or API gateway. So, there's a whole bunch of different services you can deploy at AWS, because remember, these things are out on the internet. There are going to be bad actors out there on the internet to be able to do that. So even before getting to your front door, getting to your API, a whole bunch of security options you can do. And they're different things that are happening. There's not one security product that does them all. And then once you're through your API gateway, well, then you're internal to AWS, and it's IAM, and it's then using, a blocking against SQL injection, and it's, making sure that all those kind of things that you would probably do in a traditional environment as well also apply. But because you're building serverless services, I would say it's hopefully a little bit easier, because you've got a lot of IAM in the mix, and I think IAM is the magic which avoids having to do a lot of network security. My thought.
And also think about the chance to reject that malicious traffic, that request, as close to or as early in the process as possible. Let's say if it gets caught by WAF or CloudFront in general, Shield and WAF, it means that it doesn't reach your API gateway, and you do not pay for that request to S3. And then let's say if API gateway rejects that request, it does not execute your Lambda authorizer, for example. You do not pay for that, because you can skip all the front part and then just have API gateway exposed without any additional security and just rely on authentication authorization. But let's say if you use Lambda authorizer and if you have the DDoS attack, instead of distributed denial of service, it will become, and that's not my term, distributed denial of wallet attack, because you are paying for those executions.
Yeah, absolutely.
Okay, and moving on to deployment and publishing.
You were just going to quickly mention the partner solutions, because I know we've talked about some of the AWS services, but yeah, the partner solutions are a very big part of API security, and also very likely you could very well be using one of these partners as well. And as we mentioned earlier, because APIs are a common industry kind of thing, a lot of these partner solutions which you use elsewhere is also helpful with API Gateway and other parts of the stack.
Yes, and they would include payload analysis. You can put them, there are ways to put them in front of API Gateway if you need, let's say, web application firewall that is not AWS. Let's say you have some requirement by your enterprise security team that we will use only this web application firewall. So those security partners play a role there, testing and so on. So all those security partners, so security solution partners that you may see in enterprise, if they have anything API specific, most likely they will integrate with the Amazon API Gateway as well. So take a look at them. And then deployment and publishing, as I mentioned already, it's again not really specific to API as any other software product or service product, and it will include most likely that pipeline will include most likely more than just API. You will have this implementations included like Lambda functions, creating DynamoDB tables. I hope it's not in the same stack, because then it's a matter of time before you wipe out your database while you're deploying a new version of your stack. But those are best practices for CI/CD and deployment practices in general. So you can use AWS services like Code Pipeline, Code Build, Code Deploy, or any other product or service that you are familiar with and comfortable with, like Jenkins, Bitbucket, GitLab, CI/CD, GitHub Actions, and so on. All of them will work just fine, because as long as you use infrastructure as a code approach, be it CloudFormation or CDK or Terraform or anything else, you can include that in your existing CI/CD process and then make it part of it, and make sure to include testing as part of your deployment process.
And it's part of the deployment process also as you evolve your API, going back to the lifecycle as well. Talking about canary deployments and things like blue-green deployments. That's part of your API lifecycle is built as part of the service into API Gateway with some for instance using Code Pipeline.
Yes, and scaling. We talked about it a little bit. You need to be aware of service quotas just to make sure that you submit NAT request to increase from 10,000 RPS default quota in time. But other than that, scaling is really kind of, with API Gateway as managed service, scaling is really kind of hands-off experience. You don't need to care that much about API Gateway itself. You need to make sure that entire application stack scales, and you need to monitor it to see where the bottlenecks may be there. And there are all those optimization observability features that you have available to you. But scaling itself is not really something that you most likely would encounter in typical environments. There are levels of scale where you should start thinking about slightly different approaches, like going into multiple accounts or going into multiple regions, maybe for latency reasons, maybe for resiliency reasons. And but those are not because of scaling limits. Those are mostly those architectural approaches like cell-based architecture in SaaS applications and ISVs. They are mostly because you want to have better control of your blast radius. If something happens, you want to have better control on routing. You do not want to overwhelm your backend resources. Maybe you have, let's say, if you are SaaS implementation, maybe you have multiple stacks, dedicated stacks for some of your larger customers where you want to segregate that traffic into separate account and make sure that it can scale properly, or have maybe regulatory requirements that they do not share anything infrastructure-wise. So you may have all those concerns when it comes to scaling, but it is not a really typical bread and butter API development area.
And I suppose API Gateway can help in a way because it also has a caching feature. And so because API Gateway scales so well that, you can use caching to, for example, get database information that's coming through API Gateway, cache it at API Gateway, which can help with your downstream.
Yeah, definitely. And speaking of caching, when we talk about scaling, first of all, you can put CloudFront in front of API, so all those GET requests that can share response can be cached at CDN level, not even reaching API Gateway. So that will help with scaling and cost of API Gateway. Then API Gateway has its own side cache built in where you can cache responses for those common requests. Then you have typical cache in the backend side cache, like AWS Elastic Cache, where your maybe Lambda function or some Fargate container can reach out for database response before reaching to the database. And then some of the databases have their own caching layer, like DynamoDB, DAX. You can enable that as well. So there are so many layers of caches where you can improve your latency, your scalability, and so on. And that goes back to the same notion. Look at your entire stack. There are so many places where you can optimize. Now, after scaling, so if everything works as you expected, now you want to understand what's going on. And we're splitting that into two parts. One is operational understanding, monitoring, logging, and so on. And another is insights, more from business perspective. So for operational metrics, logs, and traces, these are kind of three areas that you would focus in any serverless application or distributed cloud application in general. One of the advices, use CloudWatch embedded metrics format. It's cheaper and easier to use than custom metrics for your business insights, for your business metrics. And then for logs, API Gateway has two types of logs, execution logs and access logs. Make sure you understand distinction and which one you want to use and which one you want to have limited access to.
Can you just specify the distinction between the two? Because I know that's often a question that people ask.
Yeah, you can, going back to data plane versus control plane, execution logs would be more of API Gateway engine logs, or maybe more closer to the control plane. Even though you will see what is going on with that particular request as it goes through the system. Let's say, did it hit the Lambda authorizer? Did it go to the was it served from the cache? Did it go to the backend integration? What backend integration response was, and so on and so on. Now, access log is what you would see in any typical API implementation or web application implementation. Who made what kind of HTTP request from where, what was the response status. Now in execution logs, you can specify a log level and you can log full request and response. So that's where what I was referring to, that you should understand what is available where and make sure that access control to those logs is proper. Because if you have any sensitive information, let's say any PII coming in through the request as part of that payload, it will be logged in execution logs. So make sure that CloudWatch execution logs have retention policies that are aligned with your overall policy and requirements, that access control to that is proper. Now, access logs, they don't have, except for query string and then the request path, they don't have payload information. So that may be easier. You still may need to apply some masking and so on, but it's slightly different type of log. And in case of access logs, you have flexibility to specify what format do you use and what should be logged. You can build your specific structure for that log, which fields should be included. And then for control plane, going back to data plane versus control plane is logged in CloudTrail. So any API calls that are hitting management API management, configuration changes, and so on, that will be logged in CloudTrail. And traces. You can use X-ray for traces, and you can also specify sampling rate. So API Gateway by default is tracing first request every second and 10% thereafter. Though you can specify if you want, let's say 100% of tracing, and then every single request will be traced through the system. And that may be kind of expensive logging engine if you do that, but some of the customers, let's say if they want to trace every single financial transaction for particular path or for particular resource in your API, they may do that. In that case, you see where that request goes. You see all the additional information. If you instrumented your code and it has annotations for traces and so on, you will see that directly in API Gateway request trace. A couple more features maybe not as well known. Service Lens and API Gateway is there as well, where you have that integrated CloudWatch logs, metrics, and traces into one overall glass of pane. So you can see what is going on and then traverse it. And also synthetic monitoring. Well, you can specify canaries and then have that synthetic monitoring configurable scripts and so on that will let you know what's going on and if you have any issues even before it becomes obvious to your customers that something is broken. A few more dashboard, a few more things to keep in mind when we talk about observability dashboards. You can use CloudWatch to build dashboards, and this is an example of a dashboard that includes both business metrics and operational metrics, and from multiple services. And you can do that in infrastructure as a code. When you are building your service, you can define your dashboard as part of that deployment stack. You don't have to go into CloudWatch and then build it by hand. You can codify it. So look at that, and I think there is a link to the example implementation that has that observability built in, where business metrics are included along with operational metrics in a single dashboard, and CloudFormation outputs have linked to that dashboard that you can use. And business metrics, again, back to the embedded metrics format. Use that to emit your metrics that are not system, not operational, but let's say how many requests I served for this particular user, or how many widgets I sold as a result of this let's say shopping cart, checkout call, and so on. So that will give you visibility into what's going on with your API from business perspective, not just is it up, is it running. You also will know, do I sell anything through that?
Okay. And
typical, again, open source tools like Managed Service for Prometheus, Managed Grafana by Amazon, distro for OpenTelemetry. You will need to instrument your code a bit. And then partner solutions. All observability-focused partner solutions would have something for system observability when it comes to API Gateway. So Datadog, Splunk, Sumo, some of them will have more API Gateway specific solutions like dashboards in Datadog that are specific to API Gateway. They have a separate integration for that. Or let's say Sumo Logic reports on the logs that are specific to API Gateway, and so on. Now, another part of observability, it's not exactly observability, it's more of an insight. You have, besides knowing how many requests were made, you need the insight into how that system behaves. One reason is troubleshooting. If something goes wrong, you need to understand, you have to have that insight. And that's where CloudWatch Log Insights really helps, because you can search through those logs and visualize them in a flexible way and include multiple log streams in the single request. So really powerful tool. If you haven't looked at that, take a look. And also in serverless land, code snippets area, you can find typical troubleshooting queries for API gateway. So go there, search for them, and take a look. Maybe have them bookmarked, and see how they can help you if you need to troubleshoot something. Like, what are most often failing requests? What are paths where you have most of the 500 response status codes and so on. Also, contributor insights. And contributor insights allows you to see who is impacting or who is contributing to your metrics or logs most, like top N contributors, total number of unique contributors, and so on. And you see a screenshot from setting up sample rule in contributor insights that has entire set of queries for API or rules for API gateway, falls by route, calls by IPs, and so on. So you will have much better view of who is using most of your API gateway from different, looking from different angles. Then some DIY solutions, because access logs can be streamed to Kinesis data stream or Kinesis Firehose. You can stream it to S3 and use analytics services like Amazon Athena or Amazon Glue to analyze them and have different abilities of slice and dice them and visualize using Amazon QuickSight or Open Search Service. All this is available for you. You can do that in a straightforward way. And here's an example of, let's say, API keys usage using visualization using QuickSight and Athena. And link to the blog post that implements this is on the right-hand side along the resources. And again, partner solutions. So this list is shorter than observability. In this case, it lists partners that have API gateway specific insights, like Moasif has really interesting reports, especially when it comes to monetization, when it comes to API key usage and so on. So all those business insights that you may be looking for may be available in those partner solutions. Moasif, Sumo Logics, I mentioned that they have reports that are specific to the gateway. Datadog has dashboards that are business oriented and so on. So take a look at their solutions. It may be something that you always looked for but never ended up with.
Yeah, Giedrius, we are running slightly short on time, so
okay.
Yeah, let's.
Okay, last two parts.
To get to the Discover one, which is, I know, very useful for people.
Okay, so I'll skip through monetize, because in most cases, monetization, if you need monetization, just let your account team know and AWS account team know, and then they can find us. But in essence, it's you can use usage plans, you can use segmentation, and just go to this guide and look at that.
It's a good guide.
And discovery. So nobody is publishing API just for themselves. As we talked at the beginning, it will be their partners, it will be their internal customers. So you need, in many cases, you need portal. Now, depending on your API user nature and number of those APIs, it can be as simple as open API definition or some static page hosted on S3. If you do not change, if you have really static API, you don't change. Okay, you can point your users to that documentation, to PDF file in S3 as the simplest implementation. Now, if you have large number of customers, but they are going through kind of handhold onboarding process where everything is done by your customer enablement team, maybe you don't need it either, because enablement team or your professional services organization will do that. Now, in other cases, you need developer portal. So you have two large groups. One is self-managed. It can be either serverless developer portal. It's still available. It's in maintenance mode, but it's still available on GitHub. Or also you can consider Backstage. So CNCF project that works well with API gateway, and you can use, especially if you have a lot of containerized resources and you have experience in managing containerized workloads. Backstage most likely is already there because it's quite a popular project, and it may be, especially for internal APIs, it may be appropriate tool to use. Now, if that is not an option, again, back to partner solutions. One of them is referred in API Gateway documentation, README. Also APIable and Swagger Hub by SmartBear. All three of them are available on AWS Marketplace.
Giedrius, I'm going to have to jump in. We've literally run out of time, and we don't want to crash into another stream. Giedrius, you've done an amazing job. So much good stuff. I've put up the learning guide. Thank you so much, everyone, for joining us for Serverless Office Hours. We'll be talking about more exciting things next week, same time, same place. Thank you.